在正不正确。
And the best way for us to do that is to see if dark energy is exactly created with space, or a little faster, or a little slower.
那我们要看的重点就是，暗能量在创造的过程是跟宇宙一样的吗？就是宇宙如果扩张1倍，它就增长1倍，还是它的速度是稍快或是稍慢的？
So it turns out this matters for the future of the universe. The first is what we call the big chill. Imagine Einstein is right, and dark energy is tied to space itself.
那我们现在来宇宙的未来，假设爱因斯坦的这个说法是正确的，暗能量能确切的随着空间而创造。
Then it turns out dark energy has already won the battle of the universe, and will continue to speed the universe apart over time, faster and faster.
那就是暗能量赢得了宇宙这场战役，未来的宇宙呢会以更快速的速度去膨胀。
Eventually, the creation of space will be happening faster than light can travel through the space.
膨胀的速度会快到这个光速也赶不上。
And galaxies we see now will become invisible.
那我们现在所看得到的星系，到未来也会都看不见。
Only the very nearest by galaxies, where the gravity, our mutual gravity, is so strong that the universe is not expanding.
只有离我们很近的这些星系呢，才会因为重力很强的关系，它不会去往外扩张。
Will remain in view in the distant future. So only those galaxies which are together will remain in view.
只有非常少数的星系在未来才会保持这种以重力去主导，而不去往外扩张的状态。
And those galaxies will eventually merge with our own galaxy and form one giant big galaxy.
那些邻近的星系跟我们自己的银河系，到时候会汇聚在一起，形成一个大的一个星系。
And beyond that, there will be nothing.
那除此之外，就是一片荒芜。
So we always tell our funding agencies that we need to do cosmology now before it's too late.
我们常常告诉赞助商说，我们现在就要做宇宙学，要不然会太晚了。
Because in 100 billion years, there will be nothing left to see.
因为再过1000亿年，就什么也看不到了。
A more exciting, very speculative end to the universe is called the Big Rip.
那另外那个有可能的宇宙未来状是我们称为大体的状况。
And this dark energy gets created faster, just a little bit faster than space gets created.
那在这样的一个虚拟情境里面，暗能量产生的速度比空间产生的速度还要稍快一点。
This type of dark energy can actually rip apart space where gravity has already won domination of the universe.
在这样的虚拟情境里面，连原本重力已经主宰的这些空间里面，暗能量也会获得胜利。
And it can even get into the atoms of your body and rip you apart at the subatomic level.
它甚至呢会渗入你的身体，因为你的身体是原子组成，它以次原子的方式渗入你的身体，然后把你撕裂开来。
And this would really leave nothing, with every quark in the universe separated from every other quark in the universe.
那宇宙所有的这些组成的分子的元素，全部都会分散开来。
It would be a very spectacular end to the universe.
到时候会是一场非常惊人的奇景。
As we would watch the stars in our galaxy disappear about 15 minutes before we got ripped to shreds.
我们先是会看到星空一片成为天女散花般的散开，15分钟之后，我们自己本人也会被散开，整个爆炸撕裂开来。
But don't worry, we have at least 100 billion years
不过大家不用太紧张，因为我们还有1000亿年才会到那一刻。
until this could possibly happen.
那个也还只是虚拟的情境之一而已。
So, I will conclude reminding you that it appears this is the way the universe ends, not with a gnab, but with a whimper, or just possibly in a scream during the big rip. Thank you very much.
谢谢各位。
Thanks very much for a wonderful talk, and
Thank you very
in a
much.
way that I guess most people will understand. Do we have a few minutes to entertain a few questions? 我们在座的来宾有没有什么问题？中文或者英文、台语。Yeah， 关于宇宙的未来。
At the high school, every student had to ask a question.
Okay.
Every student.
If they don't ask, they're not allowed to leave the room.
I think they get into trouble.
They get in trouble.
We have a question there.
OK， 你要拿麦克风吗？我那边有。
You and I can share a microphone.
According to your results, it looks like that the dark energy is the origin, or we can say the source of the anti-gravity. So, besides your observation or your experiment, is there any other experiment that can prove the dark energy is the origin of the or any other relation with the anti-gravity?
Okay, do you want to translate first, or I'll give an answer and you translate? Yeah. So, dark energy is inferred by our experiment and those other experiments I have shown, and there are some other experiments I haven't told you about tonight. Essentially, every observation is consistent with dark energy. But until you can actually see it or touch it, which it turns out is almost impossible to do, it is very hard to know for sure that dark energy is the correct answer. Especially since our theory of dark energy is very poor. It is really a cartoon that Einstein produced all those years ago, and it's not very satisfactory. And so I think we're all looking and hoping and looking for mistakes in the Einstein version of it. But at this point, it seems like everything else Einstein did to more or less be perfect.
Yeah, 刚刚Brian 刚刚讲的是说，除非有一天你能够碰到或者摸到或者看到暗能量，其实你还是没有办法说它就是我们寻找的答案。但是呢，他现在所做的很多，他们牵涉到目前所做的很多实验跟观测，他刚刚没有告诉我们的，都很跟那个黑暗能量的解释是非常符合的。所以现在看起来，爱因斯坦当初说的可能是正确的，就像爱因斯坦说的其他东西一样，或多或少都是正确的。Yeah. OK， 那边有。
请问一下，那个最后这个结论哈，也不是结论，就是有几种可能哈。尤其是那个暗能量，是不是 imply 是不是有另外的其他的世界，或者一些multi dimensional 的东西，跟这个有没有任何的相关或者可能性？
Yeah, the several conclusions you just made, do they imply the possibility, the existence of other worlds, multi-universe, and so on?
So, some very famous theorists are trying to make this